A very good morning to all the St. Marians of class 7th. How are you all students? Enjoying at home? So again this is Zeba Anjum, your computer teacher with your computer book. Let's click by Friends publication. Now students, today in this video basically we are going to see your chapter number 2. In the previous video we have seen your chapter number 1. This is basically the content in which you are having at a total 11 chapters. Now let us see the first chapter about your computer hardware as well as software we have completed in the previous two lectures. Okay, I have also given you the questions and answers. In case you have not completed the work, then please try to do it in your copy as soon as possible and try to learn it also. Okay, now see over here in this video we are going to start your chapter number 2, that is your number system. In this chapter we are going to see what is a number system, how many different types of number system we are having, what is the meaning of that base, now how to convert one number system into another number system. Basically the conversion we will learn in these two types of number systems. Okay, binary to decimal as well as decimal to binary. Getting? And at the very last we are going to see what your binary arithmetic, in which you will be doing addition, subtraction, multiplication as well as division on your binary numbers. Okay, so without wasting any more time, let us start your unit number 2, that is number system. Now students, turn on your page number 14 of the same book. You can see the same number system chapter. Now see the first portion, that is introduction. So basically in the introduction portion we are going to see what is a number system and what are all the things that we have to focus so that we can understand these kind of number systems. Okay, now a very simple example. Let us take any number. You can take 56. Okay, this is basically a single number. But if we talk about the digits, yes, if we talk about the digits, that it contains two digits, 1 5 as well as the second one is 6. And in this chapter we are going to see that how this overall number, that is 56, is being determined by your computer. We know, okay, that it is 56, it comes after 55, that is 56. We know its value, we know all the things regarding it, but your computer, as I told you, only understand the languages of 1 as well as 0. Now how your computer is going to recognize this 56 as it is a 56? Okay, this is how we are going to learn in this chapter. Now see students, for understanding or for determining any number, then we have to focus on only three things. See over here the third line. The value of digit in a number system is determined on the basis of three factors. The first one, value of the digit itself. Now again take the same example of 56. The value of digit. Now see, let us break this number into two digits, 5 and 6. Yes, the value of 5 as well as the value of 6. We know what are the values. 5 is smaller than 6. 6 is more than 5. So such kind of value firstly we have to determine. The second one, the position of the digit in the number. It means your 6 is placed at the unit position. Yes, and your 5 is placed at your 10th position. If we just reverse their position, if I write down this 65, then number of digits are same. Yes, the type of digits are also same. Value of digits are also same, but their position has been interchanged. And because of this only position, आपका पूरा number change हो जाता है. Yes, so these are the first two main things what we have to determine. Yes, and the last one, the base of the number system. Now regarding the base of your number system, we are going to see furthermore that आपका base क्या होना चाहिए. Yes, if it is a binary, then what kind of base we are using. If it is a decimal number, then what kind of base again we are using. Okay, so furthermore if you studied this chapter, then you will get to know about the base of this number system. Okay, now students, let us see the theory portion of this introduction part. See over here in this line, decimal number system is the most popular system. It has 10 at its base. You are having 10 at its base. Now see students, the base value means what? In case you are having this 10 as its base, it means your decimal number is holding only 10 numbers. Okay, your decimal number system is having 10 numbers, and it means only 10 numbers are there in your decimal number system, and those are what? 0 to 9. 0 1 2 3 4 5 6 7 8 9. So 10 numbers you are having in this number system, and that is why 10 is its base. Okay, it consists of digits from 0 to 9. This system is used by us in our everyday life, but it is not used by computer. Yes, because computer knows only 1 and zeros. Okay, computer uses binary code representation. Now see the last paragraph, students. All digital computer stores numbers, letters and other characters in coded form. Okay, so anyhow you have to convert the number, or not precisely you, but your computer converts your number into its some kind of binary form so that it could understand those things. Okay, the code uses to represent characters in the binary code, that is a code made up of binary digits or bits. Okay, every character is represented by a string of zeros as well as ones, the only digits found in the binary number system. So your binary number system is very popular among your computers. Okay, your computer understands only this language, only this number system, but you can use any other number systems also. Okay, for the ease of yours, for the ease of your data handling purpose, आप क्या कर सकते हो, कुछ और number systems भी use कर सकते हो, but for that kind of purpose आपके computer को कुछ translators use करने होते हैं, so that it can convert some other number system into a binary number system. Okay, now see furthermore your number system. Number system is a system of reprocessing number in various ways. It denotes a group of character which denotes various numerical quantities. Yes, there are various kind of number systems. See over here students, basically we are having four types of number system, that is decimal, hexadecimal, octal and binary numbers. Regarding your decimal number, we know that the base is 10. Regarding your binary numbers, we know only two digits we can use in it, or you can say only two bits we can use. Yes, so the base is 2. Now regarding the decimal, your base is 10. Regarding the binary, your base is 2. And regarding your hexadecimal as well as your octal numbers, we are going to see furthermore. Okay, hexadecimal basically contains 16 and your octal contains 8. Okay, now see, computer Computer uses binary numbers for the internal representation of data. This representation 0 and 1 as off and on is very convenient to use within the electronic components and circuits. Now see students, basically what does it mean by this line, that 0 and 1 is only being understood by your computer. 0 means off and 1 means on. So basically these are some kind of your electronic circuits, which means if you are having 0 then it means the circuit is off, if it is 1 it means your circuit is on. Okay, since binary, now see students over here, since binary representation of a decimal number can be very large, which can be inconvenient to handle for human beings, to work with smaller expression, more number system, that is your octal 8, hexadecimal 16 have been invented. Now getting the point. See students, binary representation of decimal numbers is actually very huge and you can say very complex. Let us suppose you are having a number 51. Okay, now you have to find out the appropriate binary number for the same. Now again see, you are having 1101, roughly I have taken this example. Now again see, you are having some kind of sequences of zeros and ones. So as you grow this number 51, your binary representation will also grow. Okay, and over here in our computer system we are dealing with some complex problems also. Yes, so for handling such kind of thing, for using these number systems more precisely or more properly, that we have invented what, your octal as well as your hexadecimal number system. Okay, आपके octal, hexadecimal as well as your decimal number systems आपकी इसीलिए invent हुए हैं ताकि जो binary representation का आपका limitation था, that you are having longer form of binary numbers, आपके पास one zeros बहुत complicated हो जाते थे, and your programmers doesn't understand that what does this number mean, और इसका conversion में time लगता था. So that is why your octal, hexadecimal as well as your decimal number system has been invented. Okay, now see the next topic on page number 15. At the very top you are having base. Regarding the base we have already studied. Yes, आपकी किसी भी number system में how many digits you are holding, that is basically the base. Okay, the number system of base n has exactly n digits or symbols. Okay, if it is having a base n, then it means that number system contains that much digit only. as decimal number system which has a base 10 contains 10 digit only, that is 0 to 9. Binary system has base 2 and it contains only 2 digits, that is 0 and 1. Octal number system has base 8 and it has only 8 digits. Hexadecimal number system has base 16 and yet having 16 symbols. Okay, now this is all about your base. Now starting with your first type of number system, that is basically your decimal number system. Now see students, in your basic day-to-day mathematics you are using the numbers. Yes, those numbers are your decimal number system. Okay, so basically these are very popular. We are using these number systems in our day-to-day life. Now let us study more about them. In the decimal number system, the successive position of the left of the decimal point represent unit, tens, hundred, thousands, etc. Now see students, take an example. Let us say we are having 351. Yes, it is a number. 351. Yes, if I write down 0.00, then means what? Over here is a real part, over here is after some decimal portion. Yes, if you talk about this thing only before decimal, or you can say on the left hand side of the decimal, आपका जो ये first digit होता है, then it denotes what? It denotes your unit position. Okay, the second digit on the left hand side of your decimal denotes your tens position. Yes, and the third denotes hundreds. Yes, and as the number increases, or you can say if I write down 2 over here, then it denotes what? It denotes your thousand. Yes, and if you keep on increasing the number, the units or the these representations will also increase. Okay, that you have learned in your mathematics also. So please go through it very quickly. Now see over here we are having one more example. For example, if we consider the number 365, then the digit 5 represent the number of units, 6 represent the number of tens, and 3 is a number of 100. Okay, or you can say if you break this number out, then 3 multiplied by 100, 6 multiplied by 10, and 5 multiplied by unit, that is 1. Unit means 1, and if you do all the calculations over there, then you will be getting 365, that is your number. Okay, so quickly go through it. The first one is your unit position, the second one is your tens position, the third one is your 100 position, and the fourth one is your thousand position, and it keeps on increasing. Okay, thus as we move one position to the left, the value of the digit increases 10 times. Okay, we can see that the position of the number affects its value. So hence you can say that the position of the number is going to affect your value. That is the second point that we have learned in the introduction portion, if you remember. Okay, now this is all about your decimal number system. Quickly move towards your binary number system. We have studied already that binary number system has a base of 2. Yes, only contain 2 digits, that is 0 and 1. 0 you can say off, 1 you can say on. Now let us go through the theory portion. In binary number system, only 2 digits 0 and 1 are used. For example, the string of 110011 is used to represent the number 51 as a decimal number. As we have taken an example previously also, yes, if you write down 51 in a binary number, then it is going to give you 110011. Okay, and this number is much complicated than this number. Yes, agreed. Now see the second line. The binary system uses 2 instead of 10 as a base. Why? Because it contains only 2 numbers. The binary digits are abbreviated at bits. In computer, as the internal representation of data is done in binary number, the electronic components and circuit uses 2 states of binary number, 0 and 1, to show on and off state. Yes, as I told you previously also, 1 is on and 0 is off. Now again see over here an example, 110011. Okay, now this is basically some kind of thing that we are going to see afterwards ki how you are going to convert your binary number system into your decimal number system. For now just leave this example, we are going to study this conversion afterwards. Okay, now understand about this binary number system only. Moving forward to your octal number system, students. Now see, the octal number system has its base 8. It means it contains 8 symbols. Okay, that is 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0 to 7 it contains in octal number system. So if you write down this 252 according to in decimal position, then what you are going to do, you have to take the digits from the left hand side position. Okay, it is having a base 8, so you are going to multiply this 2 with 8 to the power 0, and again moving one step at the left position, you are going to multiply this with the 8 to the power 1. Again you are going to multiply this with 2 into 8 to the power 2. Okay, and as you keep increasing to the left hand side position, these powers will get increased. Okay, so if you add on these numbers, then you will be getting an appropriate decimal number for the same. This is basically the conversion, students. Now see students, regarding your octal number systems conversion, let us take one more example so that we can understand this thing more accurately. Okay, let us say we are having a number 121 and it is having a base of 8, and you have to convert it into an appropriate number, that is your decimal number. So what you have to do, firstly try to break these digits 1 2 1. Okay, let us take it as 4. Okay, 124. So break this digit 1 2 4, starts writing from the left hand side. Okay, so 4 is at the unit position, it has to be multiplied by 8 to the power 0. Why 8? Because 8 is the base. Okay, now again plus, take the second number, that is 2. 2 is to be multiplied with what? 8 to the power 1. Okay, now again the third one, that is 1. 1 has to be multiplied with 8 to the power 2, and as you keep on increasing on the left hand side position, these powers will also increase. Okay, so we are going to start with 0 and we will keep on increasing until we have reached at the very end of our number. Okay, now do this basic calculation using the BODMAS rule. Firstly, what we are going to do, firstly we are going to open these powers over there. So 1 multiplied by 64, then plus 2 multiplied by 8, then again plus 4 multiplied by 8 to the power 0 is what? Is 1. Okay, now students, I'm changing the color. Yes, now over there let us do the calculation at the upper part. So 1 multiplied by 64 gives you 64, plus 2 multiplied by 8 is going to give you 16, and plus 4 multiplied by 1 will be giving you 4. Now again let us try to add all those. You will be getting what? 84. So you will be getting 84 as an appropriate decimal number. Okay, so 124 to the power at the base 8 will be giving you what? 84 with the base 10. So this is how basically students we are going to convert our numbers. Okay, this is basically the conversion of your octal number system into your decimal number system. Okay, now moving on with your hexadecimal number system. Now see students, previously also we have seen what that hexadecimal number system is having your base as 16. Okay, so base 16 means what? It is going to give you 16 numbers, 16 digits or 16 characters. Okay, so firstly it is holding 0 to 9 digits as you are having in your decimal number system, and for the 10 as well as 11, 12, 13, 14, 15, basically it is having an appropriate your letters, we can say. For 10 it is going to give you capital A, for 11 it is going to give you capital B, for 12 capital C, for 13 capital D, for 14 capital E, and for the 15 capital F. So if you encounter any of these digits in a number system, then please understand that this is basically your hexadecimal number system, and give the representation automatically, or you can say you can represent them by yourself. Or you can say, if you have encountered this D in a number system, then please replace this D with what? With the value 13, because D is having what? The value 13, starts with A is holding 10, and accordingly your numbers will increase as your characters will increase. Now quickly see the example. 2f3 with the base 16 has to be converted into your decimal number system. Okay, so see students, firstly what they have done, always we are going to start from our left hand side position. Firstly take the unit number, that is 3. 3 is to be multiplied with 16 to the power 0. Again please remember, when we have done that conversion regarding your octal number system, we are doing what? 8 to the power 0, 8 to the power 1. Why? Because over there the base was 8, Now the base is 16, that is why we are using 16 to the power 0, 16 to the power 1, and so on. Okay, now please try to understand the difference. Firstly 3, so 3 is to be multiplied by 16 to the power 0. Again f is there, so see students over here, firstly f has to be converted into an appropriate number. Okay, so f corresponds to 15, hence 15 should be multiplied by your 16 to the power 1. Okay, again we are having 2 next, so 2 is to be multiplied by 16 square, and by doing simple mathematical calculation you will be getting what, 755 with the base 10. Getting the point? Okay, now see students, moving furthermore, we are having conversions of our decimal numbers into binary numbers. Till now we have seen what, how to convert our octal number into decimal number and your hexadecimal number into your appropriate decimal number. Okay, now we are going to see what, that how your decimal number system is going to be converted into your binary number system. Okay, decimal number system is having a base 10 and your binary number system is having a base of 2. Okay, now see students, very quickly, over here we are having a number that is 679. Okay, so please do that basic division operation that you are going to do when you try to find out that HCF and LCM. Yes, but the difference over here is that we always divide the number by 2, and we are having certain question as well as we are having certain remainder. Okay, so if you divide 79 by 2 at the first time, then you will be getting what, 39 as a quotient, and you will be getting over here, make a line, you will be getting 1 as a remainder. Yes, now again divide this 39 by 2, you will be getting 19 as a quotient and 1 as a remainder. Okay, now again do over there, see students over here, if you again divide 2 by 19, then you will be getting this 9 as a quotient and 1 as a remainder, and you do this thing until and unless you will be getting 1 as a quotient. Okay, now what you have to do, you just have to reverse the process. It means you have to start writing from bottom up till up. So firstly you will be writing 1 that is present at the very bottom, then 0, then 0, then again 4 times 1. Okay, so this is basically the binary representation of your 79, that is your decimal number system. Okay, now again we are having one more example. See students, 42 over there. Okay, so 42 is basically 42, divide this 42 by 2, then what you will be getting, you will be getting 21 as a question, and it is completely divided, so 0 as a remainder. Okay, again divided by 2, you will be getting 10 as a quotient as well as 1 as a remainder. Again divided by 2, then you will be getting 5 as a quotient, then 0 as a remainder. Again do this process 2, then you will be getting 2 as a remainder as well as 2 as a quotient, 1 as a remainder. Again divide this by 2, then you will be getting what, you will be getting 1 as a quotient and as well as your 0 as your remainder, and again over here we are getting 1 over there. So you have to read it from the bottom up till at the very top. So firstly you are going to write down the one that is present at the very bottom, then 0, then again this 1, then again this 0, then 1, then 0, and with a base 2. Okay, so this is basically the binary representation. Now try to understand this thing. Solve this example number 3 by yourself. I'm going to give you one more example. Now see the binary representation of, let us find out your 22. Okay, 22 is a number, is your decimal number. Now let us try to find out what is an appropriate decimal representation for 22. Okay, over here is the base 10. Yes, now what we have to do, again 22 has to be divided by 2, so you will be getting 11, and it is completely divided, so 0 as a remainder. Again 2, then 5 as a question you will be getting, and 1 as a remainder. Okay, again 2, then 2 2s are 4, you will be getting 2 as a question, 1 as a remainder. Again this 2, then you will be getting 0 as a remainder, then 1 as a question. Okay, now again you are having this 1, so over here write down 1 at the very last. Now start reading from the bottom up till the top. So you will be getting this 1 over there, 0, then again 1, then again over there 1, then again at the very last 0. Okay, so basically this one, your 10110 with the base 2 is an appropriate binary representation of this decimal number. Okay, I hope you understood this thing. Now let us see the conversion of binary number system into decimal number system. Okay, what we have seen up till now, that how you are going to convert this decimal number system into binary number system. Okay, now we are going to see the reverse one, that how you are going to convert your binary number into your decimal number position. Okay, now see an example over there. We are having this one, 110011 as an binary number with a base 2, and you have to convert this number into an appropriate decimal number. Now what you have to do, is try to take this number from the left hand side position. Okay, it means what, 1 multiplied by 2 to the power 0. Why 2? Because it is holding a base 2. Okay, then plus again 1 multiplied by 2 to the power 1, then again plus 0 multiplied by 2 to the power 2, then again plus 0 multiplied by 2 to the power 3. Okay, then again plus, I'm writing over here 1 multiplied by 2 to the power 4, then plus 1 multiplied by 2 to the power 5, and we have reached at the very end. Okay, now try to solve this one. At the top I'm going to write it out. So over here 2 to the power 5 will give you what, it is going to give you 32. Okay, 1 multiplied by 32 is 32, and again plus 2 to the power 4 is going to give you 16. So 16 multiplied by 1 will give you 16. Yes, now over here 2 to the power 3 will be giving you 8, and 8 multiplied by 0 will be giving you 0. Again over here 2 to the power 2 will be giving you 4, and 4 multiplied by 0 is 0. And again 2 to the power 1 is 2, and 2 multiplied by 1 will be giving you 2. At the very end 2 to the power 0 is 1, and 1 multiplied by 1 is basically your 1. Now do the basic calculation. Okay, do the basic calculation. If you add 32 by 16, you will be getting what, 32 by 16 if you add, you will be getting 48, and over here 2 plus 1 3, so and then appropriate you will be getting 51 as an answer. So 51 with the base 10 is basically an appropriate representation of this binary number. Okay, now understood that how we are going to convert one number system into another number system. Now students, for your understanding kind of purpose, please make a note that if you are going to convert any number system into a decimal number system, okay, now see over here, any number system, if you convert it into decimal number system, then what you are going to do, you are going to follow the same rule, that is you have to take the base n and you have to multiply every digit with n to the power 0 plus n to the power 1 plus n to the power 2 and so on. And this is what you are doing if you are going to convert any number system into your decimal number system. Whether it be an octal number system, then you are going to multiply it by a to the power 0, a to the power 1, a to the power 2 and so on. If in hexadecimal, you are going to multiply it by 16 to the power 0, 16 to the power 1 and so on. If in binary, then you are going to multiply it by 2 to the power 0, 2 to the power 1 and so on. Okay, now try to remember this thing. Okay, if you are going to convert any number system into a decimal number system, then multiply it by base to the power 0, base to the power 1, base to the power 2 and so on. Okay, now you understand this example basically by yourself. Okay, 11001 with a base 2. Okay, now an answer would be 25. I hope that this conversion is basically clear to you students. Now regarding your arithmetic, binary arithmetic, in the next lecture we are going to see that how we are going to use this addition, subtraction, multiplication as well as division on your binary numbers. Okay, so for now, for this lecture, please make a note that you have to do some questions as an homework. Now turn on your exercise portion. Over here students, on page number 22, no, not 22, please turn on your page number 23. See students, on page number 23, you are having this long answer type question. Yes, in long answer type question, you are having this third one, that convert the following decimal numbers into equivalent binary numbers. This you have to do as an homework, and please see this question number 5. convert the following binary numbers into decimal numbers. So basically, some couple of minutes before I have told you the conversion regarding the same. So please try these questions on your own. Okay, I hope that you would be able to do these questions, and if not, then please let me know when we will discuss this exercise portion. Then I will be giving you these conversions, and these conversions are very important for your exam kind of purpose. So it is very, very important, or it is very, very mandatory that you please try these number systems on your own, that your conversions please try to make it handy. Okay, so this is basically your homework, and let me know in case you are feeling any difficulty in any type of conversion. So most probably in the next week, on next Wednesday, we are going to complete our chapter with our binary arithmetic, as well as we are going to see our exercise portion. Okay, so this is for this video. Thank you so much.